Number 5. Sydney, tell me number 5. What is inertia? Good. So inertia is an object's tendency to resist change, specifically change in motion. So they resist changing what their motion is. Are they at rest? They don't want to be moving. Are they moving? They don't want to be at rest. That's what's going on here. So it's an object's tendency to resist change. Michael, what about number 6? What's Newton's first law then?
The law of inertia?
Yep.
I said it was idea that he made into a law.
Okay. What is it?
That's what it said. It says,
No. I mean, what's the law itself? It's in bold.
Every object continues in a state of rest or of uniform speed in a straight line unless acted up by a non-zero net.
There you go. You can all memorize that and write that down on all your papers for the test. It'll be terrific. Let's give you a slightly slimmed down version. There's a lot going on here, but there are 3 things that you need to know about Newton's law. So the first law needs to have the following 3 things. Objects at rest remain at rest. God bless you. Okay, objects at rest remain at rest. That's the first thing you need. Second thing you need is objects at motion remain at motion. And this is where that straight line part comes in. It's important to note, again, they remain in motion, but they remain in motion specifically in a straight line. And then the last part, unless acted on by a net force. Now, the net force also has a little bit of a caveat. It's non-zero. Your net force can be 0. If it's 0, you can't change it. You can't change the object. So here's Newton's first law. 3 things. Objects at rest stay at rest. Objects in motion stay in motion. Remember that it's in a straight line. Unless they're acted on by a net force, it can't be 0, though. It has to be a numbered value for the net force. Okay? So, every example of inertia follows those patterns. Things that are moving want to keep moving unless you make them otherwise. Things that are at rest want to stay at rest unless you make them do otherwise. So let me show you a couple of examples here. And this is what you're going to add for number 8. So I'm going to show you a couple of videos, and I'm going to do 2 demos for you. You can put down any of them, all of them, whichever one you find the most interesting. Here's the first one. I have a playing card. I have a quarter. I'm going to put the quarter on top of the playing card, on top of my thumb. Okay? I'm going to hit the card, but not the coin. So objects at rest remain at rest unless acted on by a net force. I'm going to apply a net force to the card. I'm not going to apply a net force to the coin. So the card should move, and the coin should stay on my thumb. So we'll see if we do that or not. By the way, those of you in the first 4 tables, just FYI, heads up. Here we go, 3, 2, 1. Go, okay, good. So the coin stayed on my thumb. Card went flying through the air. There is a net force applied to the card. There's not a net force applied to the coin, so the coin stays still. All right, next one. to sit back here on Anna's table. If you need to stand up so you can see it better. How many of you have ever done the tablecloth trick? Anyone ever done it before? So Thanksgiving's coming up. This is a great time for the tablecloth trick. Your parents will love it, okay? Wait until they get the tablecloth all set up, nice and neat and ready for Thanksgiving, and then grab the tablecloth and really fast pull it away, because the objects at rest should stay at rest. I'm going to do this with the cup. We're going to see if I can do it here with the cup and the paper. I'm a little skeptical because there will be a net force applied by friction, and so I'm a little worried about that, but we'll see. Here we go. 3, 2, 1. There we go. So I pull a force to this. I did not apply a force to this. So this stayed still, and the other thing moved. I'm not setting up a tablecloth full of china for every class to do the demo for. But maybe this Thanksgiving I'll do it to my mother. I'll do it to my mother, and I'll record it and then bring it in. That'll be terrific. I'm sure she would love it. Your parents will love it. Okay, totally. Just tell them that you're demonstrating physics for them. Okay, they'll be totally fine. Let me show you a couple of videos here. So this will be, like I said, like a slight break. Let's do a couple of videos. Let's pause this before I forget about it. There we go. So if you're solving it, you do F net equals ma. That's the equation you're going to use. If you're just talking about it, the acceleration is directly proportional to the net force, inversely proportional to the mass. That's what Newton's second law is. If I ask you what's Newton's second law and you write F net equals ma, that's fine, but I'm going to ask you to explain it, and you need to explain what it means. What it means is if you increase the mass, you decrease acceleration. If you increase net force, you decrease or you increase acceleration. So how is Newton's second law related to Newton's first? Here's how it's related. It shows how to cause change. So we didn't talk about this yet. I want to see if you can do it. What property determines inertia? If I have an object, what property of that object determines how much inertia it has? Good guess. All right, someone said mass. Oh, looky there. Mass is in the equation. And if you look at the inertia description, oh my gosh, my paper is getting, I gotta wash my hands. I'm just leaving trails of soot all over the place. Is it really? Oh, that's terrific. That's great. I'll definitely have to wash that. All right. So we said that unless acted on by a net force, shabam, acted on by a net force. So it actually shows how to cause change because mass shows inertia. All right. While I wash my hands so I don't get any of this on my tie, that would be the worst. Oh my gosh. Got my priorities straight. I want you to do 14 and 15. Which one has more acceleration? An empty semi-truck or a full one? Which one has more acceleration? You pushing by yourself or you and your friends pushing? Okay.
What is inertia?
What is what?
Inertia.
Inertia?
Yeah.
It's inertia.
Oh my God, that's not.
That's just me. That's just me.
Okay.
Yeah, it's inertia.
Okay.
Can you see well enough, or is that working well
Not
enough?
enough. You're gonna tell me something. This is good.
Is that working enough?
Yeah.
Okay.
I just forgot my glasses.
My daughter, she never uses her glasses.
They're in my other backpack. Such as everything else.
Well, at least you remember to do that.
That's true.
So, which has more acceleration The empty semi-truck or the full one, which has more acceleration, you push them by yourself or you push them with your friends. All right, what do you think, Joey?
For 14,
Sure.
a semi-truck with an empty trailer, and that has less mass than one.
Yes, so objects with less mass have more acceleration. So which one has more acceleration? The larger acceleration is the empty one. And again, that's because objects with less mass have more acceleration. Perfect. What about the other one? Yeah, Caleb. Good. Why? Good. So you and the friends, because if you increase the net force by having more people push, then you're going to increase the acceleration. Good. Okay. Let me pass out the homework. I'm going to get you started on it. There's one question I want to do in class together because it's a fun question. I love it. And then I'll give you the rest of the time to finish up, and hopefully you can get finished up before we go. So let me pass out practice 1. First of all, you're not going to do all of practice 1, so let me tell you which ones you're going to do. Once I get them all passed out. So we've done Newton's first law. Objects in motion remain in motion. Objects at rest remain at rest unless acted on by a non-zero net force. Super easy to remember. And we've done Newton's second law now, which is F net equals ma. So increasing net force increases acceleration. Increasing mass decreases acceleration. Next class we'll do Newton's third law. And that'll help us finish up this practice. And then we'll start doing like a bunch of the things. There's just a bunch of other things in this unit. So we'll start with equilibrium and how to actually find net force. We'll start with that next class. And then we'll just kind of work our way through that. We'll do some Newton's second law problems, and we'll do a lab with friction. We'll do friction, all that kind of good stuff. All right, here's the ones I want you to circle. So circle the ones so you know which ones are the homework. Ready? 1, 2, 3. 1, 2, 3. Back page. 6, 9. And I actually want you to do 9 first. I want you to do 9 first, because we're going to do 9. We're going to talk about 9 together here before you guys go. I want to see how many of you guys can get right from number 9. Number 9 is very tricky, so do the best you can. Good news is, every single question on number 9 is multiple choice. All of them. They're all multiple choice questions. I just want to see if you can figure them out. Because like I said, they are tricky, and they're tricky on purpose. So, they're all inertia questions. So, number 9, true, false. See what you can come up with. I'll give you a couple of minutes here to do those. You should be able to explain them. But you don't necessarily have to explain them right now.